Thank you. Good afternoon. This is Alex from MyTech. MyTech is a server company in Taiwan. We design, validate, and produce servers. So before we start, I want to special thanks to the OCP APAC, Chou and Junsu, who gave me this opportunity to speak something about edge computing and its option. And since we are a server company, so before we jump to edge server, actually we do offer server for cloud data center. We are demo 2 servers at the Red Solution booths. One of them is designed for both ORv2 and ORv3. It's a 1-socket AMD server in 2U3 node form factor. And the other one is designed for ORv3, which use 2 Intel CPU, and it's SuperRapid version. So as you know, both the AMD Genova and SuperRapid are PCIe Gen 5 solutions. Then let's go back to the edge computing. So firstly, I want to share you our journey about the edge server development. So in 2017, we made the first edge server together with ODI and ODCC in China. So it's a 2U2 socket form factor. And 1 year after, in 2018, we developed OpenEdge together with the OCP Foundation under Teleco project. And for the 2U2 socket version on the top, there are more and more generation year by year. On the other hand, in 2020, we joined the ORAN committee. ORAN means the Open RAN. So we have our edge server purpose built for the ORAN DU server. There are also 2 generations for the DU server. One is Ice Lake CPU, and then the other use the SuperRapid CPU. If we zoom in these 3 major edge computing servers, you may find we have some new design concept which is different from the traditional data center server. For example, we turn the server to be front access, meaning not only the SSD for storage bay at the front, but also the I/O and the PCIe expansion slot are all at the front. And the second is actually the depth is shorter. So from your left-hand side to right-hand side, for the DU server is 380 depth, 380 millimeter. And the one in the middle is OpenEdge, you know it's 430. And the 2U2 socket is 450. So they are short depths. The other new concept is they can handle higher operating temperature. If we benchmark 35 degrees C at the data center, for these 3 edge servers, they can handle up to 50, 55, or 65. So that's several new concepts while we design the edge servers. Then let's talk about 2 use cases, how to use this edge server. Firstly is we use that for 5G ORAN. And especially we use that for DU. And the second is how we do the AI by the MEC server. Okay, use case 1, which is for ORAN DU. As you know, there are some concept for the ORAN which leverage from the cloud. For example, they are separate hardware and software. Besides that, the ORAN also define the interface between the RU and DU, also DU and the CU. So while you design ORAN DU, several things you need to consider. Firstly, we plan to deploy the physical server at the radio site. So that means it's in outdoor. And secondly, for DU, we need to add the time sync function so that you can synchronize the timing for radios. And to handle the huge data from radio to the DU, we need some acceleration. For example, you need FEC to do the data processing. And of course, to be a network device, you need the NIC. And the NIC need to support time sync. So that's several items you need to consider. In that case, we leverage the OpenEdge server. So as you know, OpenEdge is 2U 3-node form factor, or someone do that in 3U 5-node. It's a one socket CPU per node. And there are two expansion slots. So we can use one of them for the FEC and the other for the NIC, which is support time sync. We contributed this server on the OCP, so it's available on the marketplace. So that's the way we configure it to a DU server. Then I mentioned after we joined ORAN, we have a purpose-built DU. So we understand more requirement from telcos. In that case, we purpose-built this DU in 1U form factor. So it's still a one-socket CPU. However, for the telco use case, we try to select the higher core count. For example, we select the 32 core count, so we can do enough virtualization for the RAN. And we still need the FEC, also the NIC, to offer more NIC port for connect to the front and the back. So we have two controllers on this system. So we are working in process to contribute this back to OCP. We expect it we hope it can get approval by this month. Then let me show you a use case we demo on the ORAN. So from left-hand side to right-hand side is from core, 5G core, all the way to the end user. So we use the 2U2 socket server as the 5G core server, then link to the CU, which used the OpenEdge server. Then we separated that to 3 DU, use the purpose-built DU I just mentioned, then link to a radio all the way to the end user. So in that case, your cell phone can go through this chain to access the internet. So that's the POC we demoed in ORAN last year. All right, that's the first use case for 5G ORAN. Then let's talk about the use case for MEC, which probably the idea just moving some computing power or storage from cloud to the edge to reduce the latency. So the idea is we do the AI or machine learning training on the cloud, but we do the inference at the edge. In that case, we need some edge server like this. So while we use the server at field, we probably also need to add some accelerator card, also help the data processing. And we might have some storage locally, and certainly we still need a NIC for the communication. So our idea again to use the OpenEdge. So again, it's a one socket server. Then we change the accelerator from the FEC for ORAN, we change it to GPU for huge data processing. Then we have the one of the configuration, it support E1.S, just like the partner from Supermicro mentioned, there are more and more use cases for the EDSSF. So we also designed the E1.S on this server. In that case, we can do some GPU acceleration with the data from E1S locally. Again, this spec is available on the marketplace of OCP. So if you have a chance, you can take a look. The other, we go back to our story in China. We used the 2U2 socket server to work with China Telecom. In China, the use case is to do some video streaming at a sales site. Okay, so that's the case. We use this server. It's a 2-socket server, so like I say, the idea just moved the computing power from cloud to the edge. So we still choose 2-socket server. And there are 6 4-high expansion slots. So in that case, I can use Maxima 2 double-wise GPU, or of course, you can use a single-wise GPU more. And there are 6 SSD at the front. So it can handle some data locally. We use the redundant power supply. So there are 2 power supply spec, 800 watt or 1200 watt for different GPU use case. And we also found that we need more storage at the edge in the use case I just mentioned. So we leverage the same chassis and turn it to be a JBOD design. Still, they are front SS. It's a front SS. So we put the large form factor, meaning the 3.5-inch hard drive at the front, and reserve a space for the connection between the computing server and this JBOD. So that's why the number is 11, but not 12. And still, we use the redundant power supply to make sure it can handle the redundancy at the edge. All right, so let me go back to the first slide. Okay, in that case, I tell you our story about edge server. So again, 2U2 socket is the mainstream we use in China, and they are open edge and also 1U purpose-built DU used in the other place. I can tell you our success story for the DU case. We started from some place in India. Okay, it's not a surprise to start the 5G use case in India because they need some basic construction. So that's why some of the telco in India, they adopt O-RAN concept. It's good. It's also good to see the cooperation between O-RAN and OCP so that we can have our product to be used in different use cases. All right, that's my presentation today. Thank you.